When we expand logs, what property do we use first? Quotient. Do I need to use the quotient property on this one? No, why not? Yep. No division. So we're going to skip this. What do we do after the quotient property? Product. Do I need to use the product property here? Yes. I'm going to look at the argument. What am I looking for to know whether or not I need the product property? It has anything that's multiplied. What's being multiplied in that argument? The 3 to the x and the x and the y. So how many things are being multiplied here? 3. 1 here, 1 here, 1 here. 3 things are being multiplied. So what does that mean? We're going to separate them with addition. How many logs do I need when I expand this? 3 logs. I will need 3 logs. So I'm going to write my 3 logs out. Log base 5, log base 5, log base 5. What goes in between those logs? Pluses. I can't just have log base 5. Every log has to have an argument with it. This is log base 5 of 3, whatever the first part of this argument was. So log base 5 of 3, plus log base 5 of whatever came next, x to the 4th power. And then finally log base 5 of y squared, y to the 2nd power, yes. All right, we didn't have to do the quotient property. We did our product property. What would come last? Powers. Do I need the powers property here? Yes. How many times do I need to use the powers property? 2 times. What am I looking for to know whether or not I need the powers property? Exponents. So little numbers on my arguments, like this one and this one. This goes to the front of this log. This one comes to the front of this log. So log base 5 of 3 plus 4 log base 5 of x plus 2 log base 5 of y. That is fully expanded. Do you guys have any questions for me on the first one? All right, let's look at the second one. Do I do the same process on the second one? No, this one already looks like this form here. This is expanded form. I want to go backwards and get something that looks like this. So since I'm going to be going from here up to here, what order do I do my steps in? Powers first, then what? Then product, and finally quotient. Do I need the powers property? Yes. How many times? Twice. Any numbers in front of logs, so like this 3 right here, it's going to become an exponent on the x. This 2 right here becomes an exponent on the 3. So log base 2 of x to the 3rd power minus log base 2 of 3 squared. And then I get to the product property. How will I know when I'm trying to condense whether or not I need to use the product property? If there's more than one log, with what in between them? Product property. What do we have in between our logs here? I have addition between. Do I have addition in between my logs here? No. So I'm going to skip the product property because there's no plus signs. No addition between logs. So we're going to skip this. How do I know whether or not I need the quotient property?
Oh, that minus sign.
If there's subtraction in between. Subtraction is going to turn into what? A fraction. We're going to have division. 1 log. This is going to be the top of my fraction. This is going to be the bottom of my fraction. Condensed down to just 1 log. Log base 2. And then the argument is the thing that has a fraction in it. X to the 3rd on top, 3 squared on bottom. Could you leave your final answer like that? You could. I would accept this for full points. Is there another way that you could write it that would still be correct? How else could you write this? 3 squared could be 9. So you could have x cubed over 9 as your argument. I would give full points for either one of those. If you leave it written like this, that is fully condensed. That is correct. You guys have any questions for me about the bell work? Right. I want to practice some more with this expanding and condensing stuff. So I want you guys to pull out your 8-2 notes if you haven't already. Yep, this is 8-2, about expanding and condensing. It had solving on the front, and then we did expanding and condensing. Yes, it's the one that we were working on Friday. Yep, that one right there. Yes. Up at the top, it's got like a space for your name, and then it says learn. That's the one that we're working on. We did the front and back of the first piece of paper, and we were almost done with the second piece of paper on the front side. All right, so this is on the bottom of page 3 on the 8-2 notes. Help me expand number 1. What's the first step we look for when we are expanding, like on the bell work? Quotient property. What do we look for to know whether or not we need to use the quotient property? Look for division. Is there division? Nope.
You act like you don't say stuff. Be quiet.
No division. So we're going to skip this step. And then we go to what step? Product. Do I need the product step? Yes. What am I looking for to know whether or not I need product? It's going to become addition, but what am I looking for? When I'm condensing, I look for addition. When I'm expanding, what do I look for? Multiplication. Is there anything being multiplied in the argument? 16 to the x, x to the z. How many things are being multiplied? 3. The 16, the x, and the z. 3 things being multiplied. So what does that mean for me? Yep, separate them. I'm going to need how many logs when I separate these? 3 logs. separated by plus signs. So I'm going to have log base 4 of what? 16. The first part of my argument plus log base 4 of the second piece of my argument, x. Yes, log base 4 of z to the third power. Do I have this all the way expanded? No. What do I still need to do? Powers. How many of those logs have powers in the argument? Just one, just this guy. Where does that 3 go? In front of its log, not all the way to the very front, just in front of its log. So log base 4 of 16 plus log base 4 of x plus 3 log base 4 of z. Fully expanded. Do I need the quotient property on number 2?
Yes.
Yes, why? Because it has division. So log of the top, this is my first argument. And then log of the bottom, this is my second argument. Yes, this one is a log base 10, also sometimes called common log. So log of 3x, common log of 2y squared. What goes in between those logs? Minus. Do I need the product property?
Yes.
Yes. Do I need it for this first argument? Is there anything being multiplied here?
Yes.
Yes. What's being multiplied in the first argument?
3 and yes.
The 3 and the x. Do I need it for this second argument?
Yes.
Yes. What's being multiplied there?
2 and y.
2 and y. So I have common log of 3 plus common log of x minus, and then we have to be careful. What do I need since there's 2 pieces here?
Parentheses.
Parentheses, common log of 2 plus common log of y squared. Only when there's 2 pieces in my denominator do I need to do that. If there's 2 or more pieces, I need parentheses around it. Can it be done?
No.
Exponent. So let's look at our powers property last. How many places do I need to use the powers property? Just once, just right here. Thank you. So I need common log of 3 plus common log of x minus, and then parentheses, common log of 2 plus 2 common log of y.
So we don't got to put the 10?
Nope, you do not have to put the 10 when it's a common log. Good question. If you don't see a little number, if you don't see a base, it is a 10, but you don't have to write it.
You said parentheses go for what again?
If there is 2 or more pieces in the denominator.
Okay, thank you.
So if you see more than just an x or just a y or just a number, you're going to need parentheses around those. What order do I have to do things for number 3? What order would I need to do things in for number 3?
Power, product, quotient.
Powers first, then product, then quotient. Absolutely right. Powers first, then product, and finally quotient. Do I need to use the powers property here?
Yes.
How many places?
2.
2. This 2 right here becomes an exponent on the y. This 4 becomes an exponent on the z. So I would have log base 9 of y squared. You're absolutely right. We're just reversing the process. Log base 9 of z to the 4th minus log base 9 of x. When I get to the product property, I'm not looking for multiplication anymore because now I'm condensing. What do I look for when I'm condensing? Addition. We look for logs that are being added. Do we have any logs that are being added? Yes. When you see this, it's going to change to multiplication. This argument and this argument, because these are the logs being added, we multiply their arguments and it becomes just one log between those two. So I would have log base 9 of y squared z to the 4th. And then I'm going to bring this other log down because I didn't touch that one yet. Minus log base 9 of x. Do I need the quotient property?
Yes.
What do I look for to know whether or not I need to use it? Subtraction between them. This is going to become division. This first argument will go up on top, and the second argument will go on the bottom. How many logs will I have at the end? Just one. Log base 9, and then my argument is what has the fraction. Y squared z to the 4th over x.
I have a question.
Yes, sir.
Is it wrong if you do log on top, both ends, bottom, or?
Yes. If you have a log on top and a log on bottom, that is incorrect. It has a very different meaning. We'll talk probably tomorrow about what it means when you have a log on top and on bottom. When you are fully condensed, there should be only one log left. I want you guys to take a minute and do number 4 on your own. So I want you to condense it like we did in number 3. When there's division between them, that division becomes subtraction. It's going to be whatever's on top, log of whatever's on top, minus log of whatever's on bottom. Does that make sense? Okay.
I know.
Yes, sir.
You can check this, I feel like, I don't know if this is good. Maybe with numbers is different. I'm not sure.
That looks great.
Okay.
You could simplify it further because it is with numbers, but you don't have to.
Okay.
You're right. My handwriting is so
Yep,
bad.
that is perfect.
Oh my God, thank you.
You're welcome.
I just put 1, 2, 5 square. With the king.
Do I need powers property on this one?
Yes.
Yes. Where would I need powers property at? In the parentheses. This 2 right here becomes an exponent on which piece? On the 5. What about this 2 right here? Comes an exponent on the 3. So as I start to condense, I would have log base 2 of 50 minus, parentheses, log base 2 of 5 squared plus log base 2 of 3 squared. If you wanted to, could you simplify 5 squared and 3 squared? Yeah. You're not required to, but you can. Do I need the product step here? What do I look for when I'm condensing to know whether or not I need the product step? Addition. Which logs are being added? The ones in the parentheses. So when you see a plus, this is going to become multiplication. And the arguments are what we are multiplying. So log base 2 of 50 minus, this condenses into a single log, log base 2 of 5 squared times 3 squared. If you don't put the little times in between, that's fine. Do I need the quotient step? How do you know? There's subtraction in between. When you see subtraction in between, it's going to become division when we condense, when we collapse. The argument that comes first will be the top of my fraction. The argument that comes second will be the bottom of my fraction. So I would have log base 2, single log, fraction for my argument, 50 on top, 5 squared times 3 squared on bottom. If you leave your answer like this, it is fully and completely correct. Could you simplify those numbers if you wanted to? What is 5 squared? 25. What is 3 squared? 9. So you could write it as log base 2 of 50 over 25 times 9. That would also be correct. You would not just write 25 9 though. It's not 259. You would have to show the multiplication if you did this. Does anybody happen to know what 25 times 9 is? What? 225. So you could, again, this is if you want to get real fancy with it, you could write it like this. That would also be correct. Could you simplify 50 over 225? Ten over 45, 2 over 9. Let me just write this down, then I'll answer your question. Leaving it like this is fine. The others are all variations of it. I would count them as correct. That's if you want to get fancy. You are not required to get fancy with this. All right. I want you guys to turn it over on the back and try condensing with those first 2 problems. Try it on your own. I'm going to give you about 5 minutes on your own.
Up here, 3 squared. So then I just like multiply this and still get the same answer? Okay.
Yeah. And it's okay to leave it the way you had it written. That would be totally and completely fine. I want you guys to try number 1 and number 2. Like I said, I'm going to give about 5 minutes. The only way to get better at this is to practice it. It's a brand new skill, brand new idea. Give it a try on your own first. I know it can feel overwhelming. Nope, very backside.
I do my work in these 5 minutes. I get my notes. I'm doing so good, bitch. You should be proud.
I am proud.
Did I do it right?
Yes, you did.
Oh, yes. Let's get it.
Oh my. Have we gone over this yet?
No.
Okay, then that explains it.
Yeah, we haven't done something like that yet. But it's down on the bottom because it ties together the expanding and condensing that we've worked on with the solving that we learned first on Thursday.
I think I got my second one right too.
We want to condense these, so that's exactly like the last 2 that we just did. I know you're getting frustrated.
Dude, I deserve some fire candy after this.
For the homework, do I skip potion here? Because there's not.
Mm-hmm. Yep. So yeah, we're doing them just like these 2 right here. Yes. Yes. Beautiful. I'll be right there, Mark. Yes. I mean, not multiply, but yes, you're going to have that many of them. Yeah. All right. What properties do I need to use on number 1? What properties do I need to use on number 1? Powers. Do I need to use product on this one?
No.
No, why not? There is no addition. So powers I need. So we're going to have log base 9 of x to the 20th minus log base 9 of y to the 4th. Product step we skip. Yes. Quotient property. Subtraction turns into division. This goes on top. This goes on bottom. One single log in the end. Log base 9 turns into division, so I'm going to have a fraction as my argument. X to the 20th, y to the 4th. Fully and completely condensed. What about number 2? Power and quotient. I'm going to have x to the 5th and y to the 30th. We get to skip product because there's no addition. How many logs will I have in the end when it's fully condensed? Just one log. It's not fully condensed if you have log written down more than once. X to the 5th goes in my numerator. Y to the 30th goes in my denominator. Nice work.
You're dead.
All right. Do you guys have any questions for me about these two?
No.
Cool. Let's look at the next one. Number 3 is weird. We do have parentheses around it. We have these parentheses around our argument. What's on the outside of those parentheses? An exponent. X to the 6th over y all to the 4th. This looks like stuff that we were doing before. If I forget the log in front, this looks like problems that we've done before. What does it mean for something to be to the 4th power? Multiply it by itself 4 times. So how many times are we multiplying x to the 6th by itself?
4.
So x to the 6th happens 4 times. How many times are we multiplying the y to itself?
4 times.
4 times. What do I do when I have 2 exponents like this? We multiply them. So this would be x to what power? To the 24th power over y to the 4th power. So I'm going to rewrite this log like that. Log base 6 of x to the 24 over y to the 4. Now I don't need those parentheses because I don't have an exponent outside of there.
That's it. Oh, no, we have to do it.
Now we have to expand it. What's the order that we do things in when we are expanding? Quotient, product, power. Do I need my quotient property here? Do I need the quotient property?
Yes.
Yes. Why? There's division. So this is my first argument. So it's going to be log of the top. This is my second argument. It's going to be log base 6 of the bottom. So log base 6 of x to the 24. Log base 6 of y to the 4th. What would I put in between them? Minus, subtraction. I remember this because a fraction bar kind of reminds me of a subtraction symbol. Do I need the product step?
Yes.
What am I looking for?
Multiplication.
Is there a multiplication right here?
Oh, never mind.
What about here? No multiplication in the arguments, so we're going to skip this. Do I need the powers property? Yes. The 24 comes in front of this log, so it's going to be 24 log base 6 of x minus 4 log base 6 of y. You're absolutely correct. Is it fully expanded? Yes. I want you guys to try the next one on your own. Take about 2.5, 3 minutes. Yes, you did. Just make sure that your base of 6 is written little. Right now you've got it written big. This guy right here.
Oh yeah, this gonna be
Yep.
in the extra small.
You know what?
I see my phone. I'm so tired.
Sorry, Mom. Don't pay attention.
Do I need the quotient property on number 4? Yes. Why? Because there's division. So it's log base 6 of whatever's on top. There's my first argument. So log base 6 of x cubed. What's on the bottom is my second argument. Log base 6 of y cubed. What do I put in between the logs? Subtraction. Do I need the product step?
No.
Why not? No multiplication. No multiplication in the arguments. So we will skip. Do I need the powers property?
Yeah.
Yes. This 3 comes in front of this log. This 3 comes in front of this log.
3 log 6, log base 6, x minus 3 log base 6, y.
That's absolutely correct. 3 log base 6 of x minus 3 log base 6 of y. Fully expanded. All right. One more idea that we need to talk about is these last 2 problems. Down at the bottom, number 5 and number 6, do they say expand?
No.
Do they say condense? What does it say?
Use expanding and condensing.
So looking here, we are supposed to solve using properties of expanding and condensing. So I want to look at this side over here, because here's where my logs are. Is that expanded or is that condensed? It's expanded. So we will condense to 1 log. Condensing, I look at powers first, right? Do I need the powers property to condense this? No? How do I know? Yeah, there's no numbers in front of these logs. We're only going to use quotient. Jumping ahead, but yes, we're only going to need to use the quotient property. Why? There's subtraction here. So this is going to turn into division. What will be on the top of my fraction? Minus 5x minus 35 will be the top of my fraction. What will be the bottom? 5. So I'm going to have log base 2, and then I'm going to have my fraction. 5x minus 35 over 5 equals what? Equals 8. I need to try to simplify that fraction.
The 5s cancel out. Now we're doing that.
Yep, but I have to divide both pieces here. Yes, because I do 5x over 5. You do it to both of them. We have to distribute with our division just like we distribute with multiplication. So this would be log base 2 of x minus 7. So far, so good?
Yeah.
All right. We've used our properties of condensing to get this written as just 1 log. Where we are right here, this reminds me a lot of what we were doing on the very front side of the packet of these notes. Because we need to try to find x. What would I need to do from here if I want to isolate the argument, because x is in my argument? I can't subtract 7 yet. How do I get the argument on a side by itself?
I'm trying to get x alone.
We're trying to get x alone.
Add 7.
Can't add 7 to both sides.
Oh,
No. Log is an operation that's happening to these parentheses. I can't. It's not an exponent. Look at the front of your packet. Example B on number 1. We're going to rewrite this in exponential form. Rewrite in exponential form. Which means I need to know what my base is, what my exponent is, and what my argument is. What is my base?
7. Oh, 2.
2.
Sorry.
That's okay. Here's the base. I write that down first. 2. What's the exponent? 8. So it's 2 to the power of 8 equals what? X minus 7. Here's my argument. Can I do 2 to the 8th in my calculator? Yeah, pop it in. 256. Because remember, it's not 2 times 8, it's 2 times itself 8 times.
So we have to simplify it.
You have to simplify it because what do I need to do to get x all by itself right now?
Oh, you have to subtract the. Add 7. I mean, add 7.
I'm going to add 7 to both sides. So I do have to simplify 2 to the 8th so that I can add 7 to it.
So that's 259.
No, we're adding.
263.
263 equals x. How do I know if that's a valid solution? Yep. We need to check. What are we checking for? Check that the argument does not equal 0, and it's not negative. How many arguments did we have? In the original problem? 2. I have log base 2 of 5x minus 35. And I have log base 2 of 5. This argument is positive. And no matter what x is, nothing can make that a negative. We found that x was what? We said that x was 263 minus 35. What is 5 times 263?
258.
No. 263 times 5. $1,315. If I subtract 35 from that, will that be a positive or a negative number? Yep, that is positive. So this answer is valid. Let's do one more like this and call it a day. How many logs do I have on the left-hand side? 2. I want to condense this into 1 log. Do I need the powers property?
No.
Do I need the product property?
Yes.
Yes. It has a plus sign in between it. If I'm condensing, I look for a plus. Quotient only when you see a minus. This is going to turn into multiplication. What are we multiplying? Yep, we're going to multiply these together.
4x plus 12.
Yep. I'm going to write it down like this first, just so we can see all these pieces. I distribute my 4 here. So I have log base 5 of 4x plus 12 equals 2. I want to find x. Where is x right now? By the 4, and it's part of my base exponent or argument. Argument. How do I isolate an argument? Yep, we're going to write this in exponential form. What is the base on this log? 5. So it's going to be 5 to what power? What's my exponent? Yep, 5 squared. Here's my exponent. Equals what? 4x plus 12. So 25, you're right, equals 4x plus 12. What would I do next? Subtract 12 from both sides. What is 25 minus 12? 13 equals 4x. Divide both sides by 4. X equals, you can leave it in fraction form, 13 over 4. Or you can write it in decimal form, 13.25. I need to check that that answer doesn't make either of my arguments negatives or 0. Check that the argument does not equal 0 or negative. How many arguments did we have at the beginning? 2. We had log base 5 of x plus 3. We had log base 5 of 4. Is there anything that can make this argument a negative or 0? Nope. This is positive, so I'm happy. Over here, log base 5 of, what did we say x was? 3.25, and I'm going to add 3 to that. Will that be a positive or a negative number?
Positive.
Yep, this is a positive number. So this is valid. All right. 8-2 homework. I passed it out last Thursday. 8-2 homework is due tomorrow. We will start 8-3 tomorrow. Yes, ma'am.